Here's a General Electric motor for a 3-belt Westinghouse washer from the mid 1970s for a front loader. Just wanted to show what it looks like. It's made by General Electric. Back here is the patent plate on it. It's made by General Electric. This is a Q174461, half horsepower, 1725 RPM, 115 volts, 60 hertz. And let's go ahead and put this on the tripod here. I'm going to kick it off here just to see what it looks like as far as the current and everything. So I've got this here hooked up, and I'm going to go through and measure the power and current. I'm going to hold this down here, plug it into the kilowatt meter here, see if we got any smoke or fire. Kicks a good bit. There it is, running at 7 amps, 7.1 amps. .1 amps, 119 volts, 118 volts. The watts is 217, 213 there. Volt amperes 847. The volt amperes is way higher than the number of watts because it's just sitting here idling, and then it's drawing a lot of current, but the volt amperes is out of phase 90 degrees with the power, so draws a lot of current, but there's only about 1/3 of a horsepower right now. Actually 216 going in there is actually real watts, 746 watts per horsepower, so it's even less than that. If I grab the shaft here like this, I can probably get it up to about, I'm going to burn my hand up. Get the power to go up. Anyways, that's the General Electric half horsepower motor used on a white Westinghouse washing machine from the mid 70s. This motor, when it normally just runs at 1 speed, and there's actually a couple different connections on the back. There's actually one extra connection that when the motor is on, it allows a solenoid to come in place. If the motor's not on, you can't engage the high-speed solenoid, so there's an extra connector on the back here that is used. Right now it's not connected up, but it's used normally on the washer. There's an extra connection back here that's not really hooked up right now, and one of the extra connections on there is such you can't engage the high-speed solenoid unless the motor's up, fully wound up. Now with time, this motor will probably drop down to about maybe 190. Usually it's around 200. The bearings are kind of warm up. This is actually a very good motor in the sense the laminations are really well made and everything on it. It's made in America. This motor, if you can believe it, went underwater in Katrina, and I actually, when I rebuilt the one washing machine, I swapped it out, so this is a spare motor. But I ran this motor actually for 2 to 3 years, even after it went underwater. The laminations on like this were all washed out. In fact, it's got marsh grass and everything inside of it. But I used this motor for about 2 to 3 years after Katrina, and then when I did another rebuild on it, I went ahead and took the motor out, kept this guy on the shelf as a spare. This is a very typical motor. This is the spring on here that's used for the front load, the pump. This is a spring load gizmo that goes on there for the pump. It spring loads and puts a bias on it. But during the operation of the washing machine, this motor just sits there and goes one speed and basically goes on the whole time, never stops. This motor here was built probably about 76. What's chattering here is this piece of metal over here, which is a spring. If I let this run here for a long time, it doesn't get like super warm like some other motors I've got. So the laminations, the core loss must be fairly low on this. It's kind of amazing. I've got some other ones that after a while you can't even hold your hand on it. It's got a decent amount of air going through here with the, so it takes a while for it to warm up. Now when I turn this off, you can hear the start relay drop back in. So I'm going to go ahead and turn this off, and you can hear it when it spins down. The start winding will kick in just before it dies. That was the start winding right there. If I kick this in, it's going to hit the start winding until it spins up and it pulls it off. Right there. That's the start winding. So it has a start winding, draws gobs of current till it gets up to speed, and the centrifugal clutch pulls it out. This is a 1800 RPM motor, so it's a 4-pole motor, AC induction motor. On the back of it here, since I've got this all unplugged, several different connections on here. This particular one uses 1 and 4. And 1, I believe, is hooked to the neutral. Number 4 is hot, and number 2 is the one that goes to the relay. So it won't allow the high-speed relay to go on to engage unless the motor's fully up to speed. That's just so you don't go through and have the relay try to be engaged when the motor's trying to start. This type of washing machine has 2 different types of pulleys on it, and those pulleys, there's a big relay that clicks in that has 2 different types of pulleys that go through there. And so the speed is because it goes through and has a high speed shiv and a low speed shiv. The motor always goes the same RPM, it's just the speed is governed by a switching mechanism on there. Anyways, that's the induction motor off a 3-belt Westinghouse washing machine. They were built from about mid-50s up until about the late 80s. And then they had a version that was the same mechanism, but it had a direct drive motor, and it would reverse. This motor only goes one direction, and that's the way it works.